Hey there and welcome to this channel, which I've created to help out other IB students or those who are joining or gonna be joining. Now I will try my best to give the best explanations possible, and I'm partially doing this channel because of CAS, so I can give also advice out on CAS and TOK, well, as much as my knowledge can give you any information on those two subjects. But basically, I will be starting out with this video with the biology unit, the first one, and I will also be doing other subjects, and I will be doing probably chemistry parallel to it because it most also connects. But I'll take up any recommendations, anything that you guys wish for. So now we can go into the video about our first topic, which is about water. Basically, water has always been essential to life, and there is a competing hypothesis about how the first cells originated, and this is something we're also probably going to talk about, but all agreed that water was essential. Now, evidence suggests that liquid water has existed on Earth for more than 4 billion years. Now, water was required for, of course, effective interactions of naturally formed molecules of life, allowing growth and copying of these molecules, as also the formation of compartments, which allowed the development of internal chemistry different from the surrounding environment. So now we come to the structure of water. Well, the chemical structure of water. So a water molecule is formed from one oxygen atom covalently bonded to two hydrogen atoms. However, the pair of electrons in each covalent bond is not shared equally between the oxygen and a hydrogen atom. This is because a property called electronegativity, which measures how strongly the nucleus of an atom attracts the electrons it shares with another atom. Now, electronegativity, that is something you're gonna learn more about, or a bit more about, in chemistry. So you have biology and chemistry. You're gonna see that a lot of the things, which makes sense why you would have biology and chemistry connect with each other. It's gonna help you out, especially chemistry in biology. Now, the electronegativity is influenced, of course, by the number of protons in the nucleus and the numbers of orbital levels in the atom. So the oxygen is more electronegative than the hydrogen. Therefore, overall, the oxygen atom attracts the shared electrons more strongly than does the hydrogen atom. The uneven sharing of electrons is a polar covalent bond. A water molecule is a polar molecule, as it shares electrons spend more time with oxygen atoms. The oxygen side of the atoms has a partial negative charge, making it the negative pole. The hydrogen side has a partial positive charge, making the positive pole. Note the geometry of the water molecule. The hydrogen atoms are at an angle of 145 degrees. Now, in this picture, you might see it better because the other one's a bit cut off, but I'll also put it in bullet points. But basically, what it means that is we also learn in chemistry, we have more different chemical structures that you can learn about, which have different degrees of angles. And well, you're definitely gonna learn way more about that in chemistry. Trust me. In biology, is not gonna have much of that, or at least you're not gonna have to memorize more than maybe water and maybe another chemical structure, but in chemistry. But you're probably gonna do this in chemistry too, so you don't have to worry about that too much. You're probably gonna remember that. So at the angle of 104.5 degrees, not in a straight line. This is because the pairs of the electrons repel each other, so they move as far apart as possible in the 3 dimensions. Then, while you're drawing the water, the element symbol is used to represent the atoms, and a solid line is used to show the covalent bond, which is a stronger bond, and we'll come to the other bond in a second. And the subscript plus and minus symbols show the charge of the atoms, and a small delta sign shows the charge is partial. For example, the oxygen in the water would be O delta negative. So basically, it would be written like something like this. Oh, okay, this is harder than I thought on a laptop, but like this, and then negative. And yeah, as you can see here, I've already underlined it. This is basically the sign, but of course the delta negative sign is it's gonna be written smaller, of course. But this is in generally everything that you kind of need to know about the structure. So now we have the bonding between water molecules. Now the partially positive hydrogen side of one of the water molecules is attracted to the partially negative charge on the oxygen side of the water molecules, as you can see right here. Oh, okay, this that did not go well, but basically that. So then one set of the other molecules, and then an intermolecular force known as the hydrogen bond, which are those dashed lines, holds the molecules together. Because the charges are partial, the bond is weak, and it is indicated by a dashed line in the drawings, as I said. Now in the water, hydrogen bonds break and reform rapidly between different molecules, whereas the polar covalent bond break much less frequently. Now maybe the way you can remember or memorize this is that the straight line, this one, nothing can come through. So you have to like think about it as like a wall there. You have to break, like really, like with a hammer or something, like no way going through. And the dashed ones, you can see that it's pretty easy to go through, and maybe that's how you can memorize this. Now, if you know one or the other, you automatically know the other. So if you know, okay, this one's easy to break, okay, you know that this one's harder to break. But all of this, and especially the forces, especially the intermolecular forces, all that you're gonna learn in chemistry and way more about it. So don't even worry about that too much now here. Now, the last thing we talk about is the living things and water, and especially the physical properties of water. Now, the physical properties further, you have the four main ones. The first one, buoyancy. That is a force that counteracts the force of gravity. Now, the high density of liquid water creates a high buoyancy, allowing less dense materials to float. Air, being much more less dense than water, is much less buoyant as well. Water less dense as a solid ice than it is liquid, which is unusual, but this is due to the pattern of the hydrogen bonding that develops as water solidifies. Therefore, ice floats in liquid water. Very cold liquid water is most dense, so it sinks to the bottom of the ponds, for example, preserving a layer of liquid water. That surface freezes so that life can continue. Then we have viscosity, which is resistance to flow and is related to how much energy is needed to change the shape of a liquid. Now, water has a low viscosity compared to other liquids, but greater viscosity than air. Then we have thermoconductivity, which is the ability of a substance to transfer heat when there's a temperature difference. Water has a high thermoconductivity compared with other liquids, except, of course, liquid metals. Air has a much more lower conductivity than water. Now, specific heat capacity is how much energy is needed to raise the temperature of a substance. Water has a high specific heat capacity. Air has a much lower specific heat capacity than water. This is because the hydrogen bonds between the water molecules, these intermolecular forces must overcome and increase the temperature of water. The additional energy needed gives the water a high specific heat capacity compared with air and land. Now, before we come to the examples, it's just really quickly, which I want to state is that those are pretty important to memorize because, for example, when you have tests, I don't know if your teachers do the same thing, but our teachers do have different stages or different kind of types of different levels they put in tests. For example, the first one being no or only multiple choice questions, the second one short answer questions, and the last one long answered questions. And in long answer questions, the question might be, 4 points for answering all of these in a nice structured way, plus maybe an example for each, or one, then it could be 5 points, or however they wanna state it. I'm not sure how exactly your teachers or might do it, but I remember vividly that when we did do the first unit test on this one or a similar question such as this one, did come like on it. So the chance of anything related water, buoyancy, viscosity, thermoconductivity, specific heat capacity is pretty high to come onto the either mocks exams or definitely end of unit tests, maybe even quiz. So now we'll look at an example. We have the it's called the Ringed Sea, and it lives in most exclusive in and on water, and in the cold seas and in on ice of the Arctic basin. Windshields swim efficiently with their hydrodynamic torpedo-like shape, producing drag due to the viscosity of water. They're powerful flippers exerting force against the water to propel them in their low-density blubber, increasing the buoyancy force. Now, in contrast, Rick seals appear somewhat heavy and awkward, as we can see here, on solid ice. That's because the air is not as buoyant, as we stated before, and the flipper's overall shape, while excellent and efficient movement in liquid water, are less much useful on solid ice, as we can see or perceive here. But they do have physical and behavioral adaptations to retain body heat in cold climate. That's because the high thermal conductivity of liquid water tends to take the heat from the seal's body. The low thermal conductivity of the blubber insulates the body of the seal and reduces heat loss. Further, the seal builds layers under the snow where the air with its low specific heat capacity can easily be warmed. The snow, in combination of salt water and air pockets, has a much lower thermal conductivity than liquid water, and it's therefore a good insulator. And you can see it in another kind of like a subtopic where the change in the conditions causes a shift in climate, but young seals are born with little blubber, and that's why they can only survive in warm and insulated layers. So this has been most of the ESO content. Now I'll be going into a subunit about the origins of water for HL in a second. But what I just want to tell you from my perspective is that don't underestimate biology as much. Because biology really, it's of course subjects where you cram for, memorize, except if you're like a genius with a really, really great photographic memory, or you just have the ability to really memorize everything that you read, then you probably have no problem with it. But especially HL, don't underestimate that, and you should definitely kind of repeatedly just revise for it, even if it's just every second day. Really sit down or listen to it when you're on a walk or in a car, or if you're bored. Just try, or anytime you feel motivational, just try at least 5 or 10 minutes. It'll cost you a lot, because in the end, when you're cramming for exams, subjects like history and biology, if you like revise, it's gonna save so much time, and you're gonna have so much like time for other subjects to practice for when you go into the exams or before you go to the exams. Because if you have to cram for biology and history, it's so much stuff. And of course it's manageable, but then you have to sacrifice other subjects where you really have to sit down and understand it, and it's way more difficult. So this has basically been all of the ESO stuff. Now I'll be going into the HL stuff in a moment. I just wanted to kind of mention a few things basically about biology, is to first not underestimate it too much, and to really try to revise, even if it's every second day, just for 10 minutes, 20 minutes. If you were feeling like, motivation to do some schoolwork right now, to revise it, or for when you're bored or something, to just even listen to it, some kind of like a podcast or whatever. It will help you a lot, because you realize that, for example, subjects like history and biology, they cost a lot of time, and of course you can cram for it, but also you can cram for it at the end of the year exams, but in the end of the day, you only have 24 hours, and you will have to sacrifice some other subjects. But if you keep on repeating just every day a little stuff, little things that you don't know, little things that even that you will have to study, but you said, I'll just watch a video, it still means something. It still means it's better than doing nothing. So yeah, we'll be getting into the extra stuff now. Now we're getting to the origin of water on Earth, which is an actual topic. Now we're gonna start with when the planet Earth was first formed. That was between 4 and 5 billion years ago, and it was far too hot to have any liquid water on its surface. Now scientific evidence suggests that water was delivered to Earth through many collisions with water-rich asteroids, also known as comets. Now, the rate of asteroids collisions has varied over the Earth's history, but smaller objects like meteoroids fall to Earth dozens of times a day on average. Now we're getting to the reasons for retention of water on Earth. First one being gravity, which is an attraction between any two objects with a mass. Larger objects like planets exert a greater gravitational force. As the Earth began to cool, water was able to condense, and the force of Earth's gravity helped to retain the water on Earth's surface. In geological terms, life began to evolve not long after liquid water appeared in meaningful amounts. Now, the Earth has remained at moderate temperature, with water neither boiling away nor frozen solid. The presence of liquid water as a solvent and medium for metabolism is considered necessary for life as we know it to exist. Now a maybe more interesting topic, which is the search for extraterrestrial life. And it is said that astrobiologists search for the study of life as it may exist anywhere in the universe. Most astrobiologists believe in extraterrestrial life will be found only in the presence of liquid water on other planets or natural satellites. Now, the habitable zone, known Goldilocks zone, refers to the orbital distance from a star that will result in liquid water. The planet Earth in the Goldilocks zone, the Earth is in the Goldilocks zone because its distance is from its star to the sun is neither too hot nor too cold to prevent liquid water. It is just the right distance. This is reminiscent of the children's story Goldilocks and the Three Bears, in which the little girl scorns extremes in the temperature for food among other things and seeks the happy medium. The search for other planets in the Goldilocks zone is a key focus for astrobiologists. An example of a planet that might once have had large amounts of liquid water on its surface can be found in our own planetary system. The solar system images from Mars probe to show impressions of ancient lakes and rivers that long ago evaporated and that were lost in space. Now, thank you for listening. I hope that I gave my best for our first video and the summarization. If I could do anything better, please let me know. And I'll probably do some other subjects parallel for it, and I'll definitely put in, for every topic that I do, I'll put in some past papers which I'll solve for. I'll look out and I'll pick the water ones out, and then I'll do multiple choice questions on the water ones. If I find some data questions on water which I'm not sure about, I'll definitely try to do some short answers and the long answer ones, and go through with it with you guys on here. So yeah, thank you.